Hey guys, so in this video we are going to talk a little bit about Java optionals, so let's get into it. Now, we're basically just going to cover what an optional is and why a little bit of why I think they're useful, and then we're going to spend some time talking about a mental exercise or a concept that I was introduced to by one of my coworkers just the other day after he had attended a very nice lecture at one of the universities here in Gothenburg. So let's get into it. So the basics of an optional is that you want to be able to express that something may have happened, or you may have a result of something and you may not have something. It's this undefined state where something could have happened. And what's powerful about this is that you can explicitly say that you did something that you cannot promise is always going to work the same way. Now, a great example of an optional is when usually it's something that is non-deterministic. For example, in my little experiment here, or my little demo here, we're just going to go through an email, sending an email to something. It's a classic example of a very common integration that you will have. You have your system is doing something, your user is using your system, and then you need to send an email to somebody or to the user or something of that nature. Now, usually what you do is that you have some type of email service providers, such as Mandrill, for example, or Google or whoever, and what they will do is that you will send a request to them on your account, and they will schedule a job that sends out the email to whoever is going to receive that email afterwards. Now, doing network-based programming is something that may work and it may not work. There's tons of things that can go wrong when you work with network-based programming, and that's where an optional becomes very powerful, because what an optional allows you to do is to, without necessarily having to throw an error, for example. I mean, you can throw an error as well, but what I like about this approach is that you can now, without causing a lot of issues and throwing errors and stuff of that nature, you can actually express something a little bit more. You can actually express whether or not the email was sent successfully, and you can also express that it might have not been sent successfully, and you can keep on operating on the assumption, operating on this unknown state until you get to a point where you actually need to know if you sent it or if you didn't send it. So in my little example here, we create an email address and we give it to my little email service here, and that's going to return a optional email request. Now the reason why I call it email request will be apparent a little bit later, but basically the idea here is that I don't want to get back the email that I sent. I just want to I want to put a request, if you will, for sending an email, because there's more entailed if we really get down and get a little bit philosophical about this, and hopefully that will make sense in just a moment. So what I can do then is that the optional, which is just, it takes a generic, or in this case it's going to be an email request, I can actually check if my value is present. If it is present, or rather, like, if it's not present, I'll simply say that the request failed, and then I'm just going to exit. But if it's not, or rather if the value is there, I can actually extract the value, and then I can make some operations on it. So the way that I think about this is that up until this point, it's unknown if something happened, or rather if I actually sent the email. But I can then now, in a safe manner, without causing any errors or not throwing any errors or anything like that, extract that information and use it to continue the execution of my program. Now, what I find to be an interesting mind process here is that this coworker of mine explained something that he was taught at the university by one of their tutors there. And this person described his own working process as a state transition. In other words, he always started by thinking about his starting state, and then he thought about his ending state. And what's interesting about this is that most of us, I mean, even I do this all the time, we write our software in a sequential manner. Like this, for example, I start at line 8 and then I work downwards. But this person said that he's illustrated this by saying that, all right, in the scenario, he would know that, all right, I have an email address and my desire is to send an email to somebody. And then he would think about, okay, what's the starting state? Well, the starting state is that you have an email. The end state is that you may or may not have sent an email. In other words, he wants to, at the end of the execution of the program, know what happened along the way. So he would write a state or an object that represented held all the information he needed to have in order to be certain that the thing that he wanted to happen had actually happened. So it was just a state transition. And that's where the email request comes in. If we look at this code, all it is a little object that holds the email address, a Boolean flag and a possible an exception. Basically, that's all there is to this object. And if we now look at this code, so what's basically happening here is that the logic of the program is that, okay, we try to send an email and then we check if we got a request back, and we extract that. And then when we know that we actually have a successful request that has been sent, or rather we have a return value here, we can actually check, okay, was the request successfully sent to the recipient? And if there's no errors, well, or rather if there is an error. In other words, we're now checking if we sent the email and if there was an error in sending the email. Because if you think about it logically, that can actually happen. We can send a network call to our external provider, and there could be an issue with the response. That happens quite often where you have some type of integration where you may send the data correctly to your third party, and the third party has now changed their APIs, or there's some change on their side of things that's not expected on your side, and then you have a response and maybe you have a parsing error or something of that nature. So this can actually happen. And the second case is that, okay, well, maybe everything was just working successfully. Like you sent this request and it was successfully, you got a 200 back or whatever you expect, and now you can declare that, yeah, I actually successfully sent the email. And this is very important because there's many times that I've been working where, for example, at my job, where we send an order to a third party to place an order on behalf of our customers. Now, if there is an error in our error logs, which happens quite frequently, it's actually, we are in this unknown situation. We have this situation where we don't know if the email was sent or not. So we have to get on the phone and then call our business partners and make sure that the email was sent successfully. And that's what I thought was so nice about this mentality of having in a state, either having an unknown state where you may have done something, but at the end of things, you want to have a representation of all the things that has happened. You want to unwrap this, or you want to go from this unknown state to a state where you know for a fact all the things that have happened, even if it's just an error or whatever. And then finally, we have the complete failure case where the request was not sent successfully. So if we just look at my little stubbed implementation here, this is basically how it works. So if the email address is null, you return an empty optional, and that's where this you'll see where this becomes useful. So instead of throwing an error, we simply return an optional. We may have an empty optional, and at the end of this, we see that, or rather, in the next part of this, we see that we do a try catch. We just imagine for the moment that we're sending like a network request or something of that nature. And then I'm just trying to illustrate here a flaky network connection. So if I run this, you'll see down in my logs there that we get different error messages. Basically, yeah, as you can see, we get different results depending on, yeah, we're just faking this flaky network request here, right? So at the end of it, we see here that, all right, if we fail our network request, we simply set the flag to false, and then we set the error in the catch statement here, and then we return an optional of the request. And otherwise, if the network request was successful, but we can also then check, we try to simulate that maybe there was an unexpected response or something of that nature, then we express that through an error as well. So what's basically happening now is that we have created this email request that represents all the things that we know has happened when we try to send the email. And the optional is the layer on top of that allows us to express that maybe something happened, maybe something didn't happen. And I know that this gets a little bit fussy, but what I think is so interesting about this way of thinking about it is that you start with a starting state, and then you think about what you want to know at the end of your program, and then you represent that with a class or an object or something of that nature. And then everything in between is just a state transition. I hope that makes a little bit of sense to you. It's a little bit fussy, and I'm sorry for that. But hopefully you have some small insights into optionals and a little bit of insights into how you can represent an unknown state in Java. Have a great day.